Okay, I'm here back in my office, not at the lake anymore. And we're going to talk about pH real quick. Okay, a chemical compound that releases hydrogen. So this is a cup of water, right? If that compound causes the hydrogen, this is H2O, right? Causes, or that compound in general releases these hydrogen ions, you see them? If it releases hydrogen ions, like there's a bunch of hydrogen ions, it's acidic. Okay? Releases hydrogen ions, acidic. There's a bunch of hydrogen ions. If it accepts a lot of hydrogen ions, right? It removes the hydrogen ions. There's a low number of hydrogen ions because it's accepting them. It's bringing them into the fold. That is a basic solution. Acidic releases hydrogen ions. Basic accepts hydrogen ions. So there won't be very many. And then, of course, you have a neutral. Okay? The same amount of each. So this is like pH 7. Acidic, a lot of hydrogen ions. Basic, hardly any. Releases hydrogen ions, accepts hydrogen ions. This is determined by a pH scale, which we did in lab. Our very first lab was related to pH, and basically how hot something is not related to hydrogen ions. Basically a scale range from 0, the most acidic, to 14, the most basic. As you can imagine, both those are bad for you. You don't want to be sticking your hand in something that has like a 0 pH or a 14 pH. Each pH represents a 10-fold change in the concentration of hydrogen ions. So it's a logarithmic scale. So again, oven cleaner, bleach, very basic solutions, you don't want to drink it. Battery acid, you don't want to drink it. Your stomach acid, right? Things up here that are neutral, your blood, your pure water, things of that nature, they have to be because your body responds to a pretty neutral pH of 7, except for your stomach acid, which is about a 2. Again, acid releases, base accepts, and the pH is the scale there. There is the scale. Now, what we like to have is a buffer. Buffers are substances that minimize these changes in pH. They accept hydrogen ions when they are in excess. They donate hydrogen ions when they are depleted. They buffer the solution. So you put a buffer in there and it prevents something from becoming an acid. When CO2 dissolves in seawater, it reacts with water to form an acid. This lowers the ocean pH and it greatly changes marine environments. Acid rain. This is where we get acid rain from. The CO2 in the water forms an acid. So too much CO2 forms acid rain. So in very large cities or downtown in St. Louis, you will see things that have been corroded from the acid rain. It's because there's a lot of CO2 from cars, from humans, and that mixes with the water coming down in rain and gives you acid rain. So again, here's an ocean example. You have carbon dioxide in the air from boats, from humans, from anything. It gets into the water. Again, mixes with the water, and you get carbonic acid. That's not awesome. Not good for sea life. Carbon-14, real quick. There are trace amounts of carbon-14 in the environment, and its radioactive isotope has a half-life of 5,700 years. And this is one of the ways we are dating things. We use carbon-14 dating. Basically because an organism assimilates the different types of elements in proportions that reflect their abundance in their current environment. So a fossil's age can be established by measuring the ratio of the two isotopes, how much carbon-14 is in something. Using the half-life measurement, it'll tell you about when it died based on the carbon-14 isotope amount in that organism. So that is pH and C14. And just a reminder, we're doing protons, neutrons, electrons. We only care about the outer shell. Ions are, one is taking, one is giving, and so they don't have a charge. Covalent, they're trying to share, and if they share equally, like a hydrogen to a hydrogen, a nitrogen to a nitrogen, they have a no charge. But when a hydrogen tries to share with an oxygen, the oxygen, because it's taking something, has a negative feeling, and the hydrogen, because it's giving something, has a positive feeling, and that creates a covalent charged molecule set as hydrogen bonds. And then we talked about why hydrogen bonds are amazing, and they create properties of water, such as cohesion, and the ice in my bowl is at the top, and that creates the properties of this condensation and really just makes life on Earth possible. So that is why water is so amazing. That's the end of chapter